Hello everyone. In today's session, we are going to discuss the concept of pointers. Pointers are very important and directly we can access the memory by using the pointers. We can increase the execution speed of the program by using pointers. Pointers concept is a wonderful feature of C and it is very important to know the concept of pointers. Why? Because while studying data structures, we are mainly using the concept of the pointers. Pointers play an important role in data structures and algorithms where we can directly deal with the storage. So how we are going to store the elements in the, or we can say the information in the memory, and how we are going to retrieve the elements or the information back from the memory. So directly we are dealing with the storage. So that's why pointers are very important. Let us have a discussion on pointers. Now we are going to discuss about the pointers. What do you mean by a pointer? So before moving on to the pointer, assume that I have a system which is consisting of the memory like this. My system is consisting of the memory like this. And here, this is the first byte whose address is 100, 101, 102, 103, 104, and so on. The last one we are talking about is 120. How many memory locations are there here? 120 memory locations are there. Means the my memory is consisting of 20 bytes of memory, 20 bytes. This is the first byte which can store how many bits? 8 bits. This is also 8 bits. Means the information here is stored in the form of zeros and ones. Right? This is the memory configuration of my system consisting of 20 bytes. Okay. Now, I have taken a variable, assume that integer I. When the variable is declared, then automatically the memory is assigned for the variable I. Assume that this is the place where the variable I is going to store. Why I'm taking the two locations here? Why? Because generally in my system, the variable is going to take 2 bytes, right? So this can store 1 byte and this can store 1 byte. So I requires 2 bytes of memory. So here, these two memory locations, this entire block consisting of 2 bytes of information, this is reserved for the variable, memory is reserved for the variable I. Now, what is the starting address of I, 1 or 2, right? So last location, second location is 103, but mainly when this entire block consisting of 2 bytes of memory is assigned for the variable I, then whenever anybody asks what is the base address of I, here the base address of I is how much? 1 or 2, or we call it as starting address. Here, assume that I'm taking the variable PTR variable, and this assume that it is not an ordinary variable. I is the ordinary variable, but I'm talking about PTR is the special. The speciality will be denoted like this, star PTR. We can take integer star PTR, or we write integer star space PTR. So better to use this notation. You can put star after int or before PTR. Both are valid. Integer I means ordinary variable. Integer star PTR means PTR is the special variable. The specialty is given here in the form of star. This is the pointer variable. When we declare integer star PTR, the meaning of PTR here is PTR is a variable of, or we can say PTR is the variable which consists of the address of an integer. Don't say that the type of the PTR is int. PTR is the pointer which points to the address of integer, which stores the address of integer. So in this case, assume that the PTR is also stored at somewhere in the memory. Assume that this is PTR. Okay. Now what is the PTR is going to contain? Address of I. So when we see this example, address of I means is it going to store 102 and 103? No. PTR is going to take only the starting address, that is 102. In this example, it is going to store the base address 102. So what I want to say is that a pointer variable is the variable which holds the address of another variable, basically the base address. There's the meaning. So what is the syntax of declaring a pointer? The basic syntax is like this. You mention any data type, here you put star, and here you take any variable name, semicolon. The star maybe you can write after the data type or before this variable. Both are valid. This is the syntax for declaring a pointer variable. Okay, now we will see more examples. For example, here I'm writing integer a equals to 10, right? Now I'm taking a pointer into star, and here I'm writing ptr and semicolon. Here I'm saying ptr is equals to ampersand a. You can't store ordinary numbers in the PTR. You have to store only the address. So ampersand indicates the address. If you want to direct access the memory, you have to use ampersand symbol. PTR equals to ampersand of A. In this case, what happened in the memory, right? There is a variable, but the variable here A, right? Memory location name is A. What is the value here? 10. Now, every memory location is having its own address. Assume that the address here is 100. Now, what is another variable? PTR, right? PTR is also a variable. Take the name of the variable is PTR. Okay. Now, what it is going to store? Address of A. Assume that the address of A here 100. So, we write 100. Now, PTR is a variable like ordinary variable. It is also having its own address. Assume that the address of PTR is 200. PTR stores 100, which is nothing but the address of A. That means PTR is pointing to A. Now, if you want to access the value of the variable A, in two ways we can access the value of A. How? Directly by referring to A, we can get the value 10. And also by referring PTR, indirectly, you can also get the value of A. How? By using star operator here. Before PTR, you write star operator. The name of this star is known as value of operator. Value of operator, or we say indirection operator. Indirection operator, or we write dereferencing operator. Dereferencing operator, right? So when we talk star PTR, the meaning is star of PTR. What is the value in PTR? 100. Star of 100 means value at 100 is 10. That's how we can access by using indirection operator the value of A. That is the logic. Now, see, for understanding purpose, I'm writing the addresses in decimal, but actually the addresses are stored in hexadecimal. Hexadecimal. Generally, we print the addresses either in unsigned integer form or in hexadecimal value. The addresses are always positive. How to print the addresses in hexadecimal? For example, if you write printf percentage %p double quotes close, and if you write ptr, now we are going to get the address in hexadecimal that we will see in writing the programs, right? Hexadecimal. If you write percentage %d, it is meaningless. Why? Because percentage %d means positive and negative. Addresses are not negative. They are going to take only the positive values. So better to use percentage %p, or you have to use percentage %u unsigned, right? So to print in hexadecimal, we prefer percentage %p. Now, as per the syntax, what I said, the pointer is declared like this, data type, and you write star here, and you write the variable name, any variable name you can take. So here I'm considering some examples. I'm writing integer star ptr1. Okay. Next, sorry, I'm writing here also you can write, but I'm writing here float star ptr2. Right next here character star ptr3. Now What is the meaning of this? See, the important thing here you have to understand here is the type of PTR1 is not int star here. The type of PTR2 is not float star here. The type of PTR3 is not character star here. It's not the type of PTR1, PTR2, PTR3. See, the type of PTR1, PTR2, PTR3 always positive integers. See, if anybody asks, what is the size of the integer pointer? The meaning of integer pointer meaning is the pointer is pointing to integer. The size of pointer integer, generally a machine, if integer takes 4 bytes, the size of integer pointer is 4 bytes. Now, whenever somebody asks what is the size of the character pointer, don't say 1 byte. Every pointer is of type only an integer. So maybe it is a pointer to character or pointer to float or pointer to integer. Every pointer is going to take the same size, that is 4 bytes, right? There is no character pointer, there is no float pointer, there is no integer pointer. There is only one pointer of type integer. But here the meaning of this he is, I will give one example. For example, I'm taking integer a equals to 10, float b equals to 20.5, and character c is equals to, in single quotes, I'm writing a here. Now after this, here what I'm saying here is ptr1 is equals to ampersand a, ptr2 is equals to ampersand of b, and ptr3 is equals to ampersand c. That's the meaning. That means there are how many locations? We have 1, 2, 3, 4, 5, 6. First, assume that this is A, B, C, PTR1, PTR2, and PTR3. A equals to 10, right? This is 20.5, and this is A, single quotes, and the PTR1. PTR1 stores address of A. Assume that this is 100, and this is 200, and this is 300. Address of A is 100. Now that is stored in PTR1 100. So this is pointed to A. Next, PTR2 equals ampersand B. Assume that this is 200. It is pointed to B, and this is 300. It is a pointer to C. This is the meaning, right? If you print the size of A, we are going to take 4 bytes. Size of B, float also takes 4 bytes, and the size of C, 1 byte. Depends upon the machine. But all the pointers are going to take the same number of size. That is very, very important to understand. Right. Now, can you, for example, here I'm writing integer a equals to 10. Now, can you say integer star p, and you say p equals to a? Can you say like this? No, it's not valid. We have to store only address. That is very, very important. I think this is clear for you. We will see more examples and programming we'll do in the next class. With this, I'm going to close the session. Thank you for watching.